Hi, today we're solving problem 48. The series 1 raised to the 1 plus 2 raised to the 2 plus 3 raised to the 3 all the way up to 10 raised to the 10 is this big number. We need to find the last 10 digits of the series 1 raised to the 1 plus 2 raised to the 2 plus 3 raised to the 3 all the way up to 1,000 raised to the 1,000. Now if we try to just directly calculate this and then do a modulo at the end to find the last 10 digits, this is going to give us a huge number. So let's find a better way to do this. Now one thing we notice is since we're adding these numbers together, we only need the last 10 digits at every step. But we can go further than this. When we're raising 1,000 to the 1,000, at every step, if we only care about the last 10 digits of this number because we want the last 10 digits of the entire sum. So when we're doing 1,000 raised to the 1,000, we only care about the last 10 digits. What we can actually do is, instead of calculating this value directly, we can first start with 1,000, then multiply that by 1,000, get the last 10 digits of that, multiply that by 1,000, get the last 10 digits of that, multiply that by 1,000, get the last 10 digits of that. So here what we're doing is, since our base is 1,000, we keep on multiplying 1,000, but at every step we get the last 10 digits. And this is legal because when we're multiplying, if we only care about getting the last 10 digits, we only care about the last 10 digits of the previous number and the last 10 digits of the next number. We multiply that and we get the last 10 digits of the multiplication. So that's how we're going to implement it. We're not just going to do a direct math.pow here and get huge numbers. We can do this smartly. So the first thing I'm going to do is I'm going to store a constant, which is what we need to take a number and modulo it by to get the last 10 digits. So I'm going to call this moder, because we're using modular arithmetic here to get the last 10 digits. This is just going to be 10 raised to the 10, which is 1 followed by 10 zeros. So only those 10 zeros, whatever digits fall in that range of the number we're modding by our modder, only those digits will remain. So, and since we have 10 zeros, we'll get 10 digits. So we have our modder here. Now what we want to do is we want to first go over all of these numbers from 1 to 1,000. And we're going to store this in answer. So I'm going to go from 1 to, and for a test, I'm just going to go up to 10 here. Now I'm going to map each of these numbers, so I get my number, and I want to raise my number to the number. So I'm going to create another range from 2 to the number, and this is going to represent each step of that iterative multiplication to get the power. So we start out with 2 and we go all the way up to n, and at every step of this, we'll multiply what we already have, and we'll start out with n raised to the 1, and we'll keep on multiplying it by n. So in Scala, when you're successively accumulating a value, it's really useful to use full left, which is perfect for those types of situations. So full left takes an initial value. Here it's going to be n raised, so this is starting at n raised to the 1. And it also takes a function saying, given the accumulated value and the current value, in this case we don't care about the current value because we're going to do the same thing every time, multiply or accumulated by n, so I don't care about that. And this function is supposed to return the new accumulated value. And here I'm just going to do my accumulated value multiplied by n, so this is going to give us the next level of the power. And I'm going to take this and I'm going to do modulo the modder. Now, first of all, we need to turn modder into an integer-like type, and we are actually going to store this as a long here because a 11-digit number in this case, because you have 1 followed by 10 zeros, is going to be too big for an integer, so we're going to keep this as long. Now another thing we need to change for this long shift is we're going to start out n as a long, so then we store n in the long range, and our accumulated value will then also be in as a long. Now this is going to give us back a long, and once we have each of these individual powers, we need to sum them up. And here, since all of our numbers are each just 10 digits long, and we only will have, even in the case of the big numbers, 1,000 of them, we don't have to worry about modding at every step of this. But we do need to do a check at the end that even after our sum, we might have more than 10 digits, but we only care about the last 10 digits, so I'm going to mod this sum by our modder. Now I can println our answer, and here we're running for 1 to 10, and we can copy, and we can see here that we have the last 10 digits of this series. Now we can actually go ahead and do this with 1,000, so we just change that one number, and we get the last 10 digits of the series we were looking for. That's it for problem 48. I'll see you next time when we solve problem 49.